In example 2, we've got triangle FUN. Yes, it is going to be fun to solve this. There's a reason for that. And we're given a couple sides here. N is 12, U is 6. And we're also told that the measure of angle F is 90 degrees. And I'm licking my chops at this one right here because I know a lot of things that we can utilize for right triangles. We can use the Pythagorean theorem, we can use our regular sine, cosine, tangent, the two angles that aren't the right angle, those will add to 90. Hey, this is wonderful. I do like to draw a diagram with these to make sure that I can see where these values are and if they make sense. So we know that measure of angle F is 90. We'll make that a right angle here. And then we could go with U here and N here. Doesn't matter too much where exactly they are. And then N is 12, so this side will be 12, and U is 6. And we don't know F here, we don't know angle U and angle N. So the three we need to find are the angle U and N, and then F. Right away, if you'd like, because this is a right triangle, we can use our Pythagorean theorem. So we know that F squared is going to be equal to 12 squared plus 6 squared. So F squared will be equal to 144 plus 36. And let's see, if we put those together, I think we get 180 there. We'll take the square root. This is not on the coordinate plane, so we don't have to worry about a negative value here. After all, the side lengths of triangles are distances here in this case, so they're just positive. And we can simplify this a little bit, and I think that 180 is divisible by 36. I'm not sure if that's the largest perfect square we can divide it by, but let's take a look. That looks to be the case, right? So we could change this to the square root of 36 times 5, all underneath, and that's true. 180 is 36 times 5. And then take the square root of 36, which is 6, and then leave our 5 underneath. If you were providing an approximate answer, then you could just type this in here and hit enter. So if we needed to round to the nearest tenth, you could do that. So we could also say that this is approximately 13.4. Wonderful, so we found that. So we've got F here being about 13.4. Kind of cool to be able to find the exact one as well. And now we need to figure out a couple of these angles right here. To do this, I like to use the side lengths that are given. Let's look at angle U first. So for angle U, I have the opposite and also the adjacent. So we'll use our tangent of angle U is equal to opposite, which is 6 over 12. This is a case where we're solving for the angle, so we need to use the inverse tangent. Remember, we take the inverse of a ratio to give us the angle measure here, and that's supposed to be a uppercase U if you couldn't tell. So what we can do is type this in our calculator. Oops, didn't use the inverse tangent, got to hit second tangent. And then we've got 6 divided by 12. We'll hit enter here, and that's about 26.6 if we're rounding to the nearest tenth. So U is about 26.6 degrees. We could also do another tangent and then see if those two angles would add up if we're solving for N now. So let's try that. Let's try the tangent of N. That's still equal to the opposite over adjacent, but this time the opposite is 12 and the adjacent is 6. So it definitely matters which angle you're looking at. We still need to use the inverse tangent to find that angle. So we'll use our trusty calculator. We'll hit second tan, 12 divided by 6, and we'll see what happens there. And that's 63.4. So N is about 63.4. And we probably want to use our measure of angle here. I'm talking about the measurement of that angle. So we have some values we think will work. We've got the side F, we've got U here, and N. Love to double check my work afterwards and just make sure that this makes sense. So U over here is 26.6, and N we said was 63.4, and those two should add up to 90. So if we do 26.6 plus 63.4, we do get 90 degrees. It might be like 89.9 or 90.1, depending on if you, which way you round on some of these, but it should be very, very close, if not exactly. 90 degrees. So that works. Also, we can look at our side lengths to make sure we've set up the proper ratios. You know, if you did for angle U, if you did the tangent as adjacent over opposite, which would be wrong. That's an easy mistake to make, though. These two angles would just be flipped then, kind of. So we'd want to make sure with our side lengths that this is the smallest angle and the smallest side out of all three should be across from it. And if you did happen to make that mistake and put like 63.4 up there and 26.6 here, you would notice immediately that the smaller angle, in the case if we flipped it, would be across from the middle side, and that would not make any sense at all. So we've got 63.4 here across from 12. It's the middle size angle compared to 90 and 26.6. And this 12 is in between 13.4 and 6. So this whole situation is making sense. I'm fairly confident that we have produced some correct values for F, which we did not know, and we did not know measure of angle U or N.